Now, the theory we are going to study is Whisper theory, and the full form goes like this: Valence shell electron pair repulsion theory. Valence shell electron pair repulsion theory. What does this talks about? This theory talks about the shape of molecules. Shape of molecules usually depend on minimizing the repulsions. The shape acquired by a molecule is usually the one which has minimum repulsions. I hope you understand that the energy and stability have a relation like this. Energy and stability have relation of inverse, right? You already know this. For example, if I have a stable structure, that means it will have energy low. And if I have an unstable structure, the energy will be high. So low energy structure is stable structure. And then the energy will be low when repulsions are minimum. Attraction is maximum, right? So this theory talks about not the attractions, it is talking about the repulsions. So the structure of molecule or the shape of molecule will be such that repulsions are minimum in the molecule. Now for that you need to understand what types of repulsions are there and which one will be more and which one is going to be less. So in molecules we have observed there's repulsions of three basic types: lone pair repulsion, lone pair on one atom, lone pair on another atom repel each other, and that is maximum. So atoms having lone pair are put far apart so that repulsion on lone pair is minimum. Secondly, you have another repulsion called lone pair and bond pair, because both are electrons. In lone pair you have two electrons, and bond pair you have two electrons. They do repel because they have same charges, right? Electron have same charges, so they will repel again. So maximum repulsion is between lone pair. Next is lone pair bond pair, and the minimum repulsion is on bond pair, right? So we will try to keep lone pair containing atoms or lone pairs far apart. It is not us, it is the molecule which is doing all this, or we can say Almighty God is doing all this. So let us see. Now we have already discussed this, that repulsions are in this order. Now if we have a molecule of type EX2, central atom is Z, and X are surrounding atoms. So there is no lone pair and they are arranged linearly. That means 180-degree opposite they are arranged. So the repulsions are minimum. So linear shape, we call the molecule shape as linear. And if we have a molecule say EX3, we have surrounding X atoms 3 in number, and central atom E as 1. So in EX3, the atoms are arranged at farthest distance. So the maximum distance they can be. So the maximum distance is when they are placed 120 degrees. So the shape goes like this: trigonal planar. This was linear trigonal planar. If in place of one atom there is another lone pair, they will be arranged like this, and the bond angle, because this will repel this bond and this will repel this bond, so bond angle will be less than 120. In this, the bond angle was 120, in linear shape 180 degrees. When lone pair comes, bond angle decreases. I'm telling you this. Remember, this is a trick. Whenever lone pair increases, the bond angle decreases. Lone pair disturbs bond angle. When lone pair comes, then the bond angle is not perfect. It will always be lesser than the value expected, right? So in EX3, there was no lone pair, but here we have lone pair. So bond angle is less than 120. Similarly, if you have 4 surrounding atoms in EX4, so bond angle is 109.5 or 109 degrees 28 minutes. When one lone pair comes, the shape is called tetrahedral. And when one lone pair comes, shape is called trigonal pyramidal. And when two lone pair comes, the shape is called bent or V shape. Similarly, in sp3d hybridization or EX5 arrangement, we have trigonal bipyramidal geometry or the shape. And when one lone pair comes, the shape becomes seesaw. Why we are keeping the lone pair in the equatorial position? Because in the equatorial position bonds are 120 degrees far apart. So the distance is more, repulsion is minimum. If you put in axial, the repulsions are more. Similarly, when you have two lone pairs, shape is T, and when you have three lone pairs, shape becomes linear. And all the lone pairs in such arrangements are kept at equatorial bonds. And last one is EX6, when surrounding atoms are 6. So the shape is like an octahedral. Shape is like an octahedral. And when lone pair increases one lone pair, the shape is square pyramidal, and when two lone pairs are present, the shape is square planar. When how you are going to figure out how many lone pairs are present? I'll tell you quick trick for that. The number of lone pairs you can find out, the value of number of lone pairs on central atom equals to H minus surrounding atoms. H minus surrounding atoms. You can figure out, for example, if I take PCl5, the value of hybridized orbitals or H, it comes out to be 5, and surrounding atoms in PCl5 are 5. So 5 minus 5 is 0. So lone pairs in PCl5 is 0. Another example, if I take PCl3, in PCl3 H value is again 5, but in that surrounding atoms in PCl3 H value will come 4, sorry. So H value comes 4 in PCl3 and surrounding atoms are 3. So 4 minus 3 comes out 1. So PCl3 has one lone pair, whereas PCl5 has 0 lone pair. Similarly, you imagine any molecule, you can figure out the number of lone pairs on central atom. This is the smallest trick I told you just now. I hope this will be helpful for you. Thank you.